Hi, in the previous video we revised a little bit the use of Lagrange multiplier and optimization under constraint. As it happens to be, we use Lagrange multiplier in economics very often. And there are two main applications of it that pop out all over economics. The first, let's start with the second one. Second one is when we try to find optimal level of inputs the company should use in order to maximize production or in order to minimize the cost of production. However, we're not going to be doing this right now. We're going to take up the second major theme in which we use Lagrange multiplier. And this theme is customer's choice theory. I know that you've been actually discussing brief elements of customer's choice theory in your introduction to microeconomics class. However, we will need to use more structured and a more mathematical approach to the problem, but this in turn will allow us to give a very specific answer to a particular question that's been going on economists' minds for quite a while. And but before we do so, we need to get back to basics. So let me just first illustrate a couple of concepts that we're going to use in customer's choice theory. And look, let's start with the main thing for us, which is utility. Utility is a satisfaction received from consumption of a given good. Okay, this is an abstract thing. There's no such thing as utility that we can actually see anywhere. But however, when we think about how a customer makes his or her decisions, the best way to do it is to have like some kind of a meter of how happy the customer gets when he or she consumes some goods. And so we're going to call this utility. So imagine that now we can measure how happy somebody is because of the consumption of some good, and we measure this happiness in terms of utility. Okay, but again, let's put more precision into it. The next term I would like to introduce to you is total utility. And total utility we will be denoting with letter E. So, what is total utility? Well, this is also a satisfaction received from consumption of a given number of goods. Okay, look, actually what we did now is we made the term utility more precise. So total utility means the total satisfaction you get out of consuming some goods. So if you consumed 3 sandwiches Then total utility will give you a number which tells you how satisfied you are because of eating 3 sandwiches, or because of drinking 2 beers, or generally doing something in bulk. However, of course, if you just eat 1 sandwich, still you can calculate total utility. Total utility out of consuming just 1 sandwich, right? But look, this allows us to mathematize this a little bit. First, I can introduce here utility as a function of x. And in our case, x denotes here quantity of a good. So this is a quantity of a good that is being consumed by the customer, right? And depending on how much do we consume, depending on how much do we consume, right? We will have a different different utility. Okay, now the second term we can introduce over here relates to change in utility. Okay, because look, if you eat sandwiches, do you expect the first sandwich to give you the same satisfaction as the second one, or as the third one, or as the sandwich number 52? Well, not, right? So we are actually expecting that utility of what we consume will be different for different units, right? This is why we are introducing here another term. But actually, we can introduce it a little bit differently. Look, if I want to know by how much my satisfaction, total utility, my total satisfaction changes if I'm consuming 1 additional unit, what do I need to calculate? Look, as always, when we talk about change, we need to calculate the derivative. And look, it turns out that if I'm going to say utility function and I'm going to differentiate with respect to x, what I'm going to get, we will be denoting usually as either u prime or mu, and this is marginal utility. Okay, so we know that marginal utility is calculated as the first derivative of the total utility function. So what is marginal utility? This is satisfaction received from consumption of 1 additional unit of a good. Okay, and look, this actually starts to paint us some picture, right? We clearly see that what we need are just these 2 terms. From this moment on, those are the ones we will be using. Just what I want you to remember is that total utility tells you what is the satisfaction that you've taken out of the consumption of a given number of goods. 7, 10, 1 billion. And marginal utility tells you by how much your total satisfaction, so your total utility, changes when you consume one additional unit of a good. So basically, how much additional satisfaction you can get out of the consumption of this additional good. Okay, so now look. Now that we know what total utility is, and now that we know what marginal utility is, maybe we can say something about the utility function. And look, as it turns out, this utility function that tells us what is the satisfaction taken from consumption of a given number of goods can be described using derivatives. So look, I could impose some sign restrictions on two first derivatives of this function. And by doing so, I will be able to get an approximate shape of the utility function. However, look, I cannot just assume that away out of nowhere. We need to have a good reason why things should be behaving a certain way. As it turns out, economists established that the pattern of derivatives that describes it best is first derivative is positive and second derivative is negative. Look, what does it mean? Look, this means that if I want to draw total utility function, so over here I'm measuring what is the total satisfaction taken out of the consumption of next and next and next unit of good X. The shape would go like this. Okay, why such a shape? Look, this first we started 0, right? We are assuming if you're not consuming, you're not getting any satisfaction out of consumption of this good. I think nobody's going to argue with this. However, let's notice something else. Look, here we see that with each consecutive good, we consume, then customer satisfaction is increasing, right? And it makes perfect sense. Everyone would rather prefer to eat, let's just say, have more than less, in general. And this is what we are assuming, right? Of course, there are cases in which maybe this is not the best option, but with most goods, the more the better is, let's just say, what we could say in principle. And this is definitely what we see. However, please notice something, that at the beginning, first increase, let's notice just the one here. We've consumed first good. And look, we see the total satisfaction is rather high, right? And consume the second good, we see that the satisfaction is high, right? Now, however, look, we can clearly see that this distance over here, let's call it delta 1, is clearly bigger. Is clearly bigger. And for example, this distance, right? And we would expect now that if we would have here a third unit of a good, the distance we would have here would be even smaller. And this is the pattern that we observe, right? Why is that so? Look, think about it as coming to a party, very hungry, and there are those tiny sandwiches. Of course, when you're very hungry, you get the first sandwich, it tastes really good, right? Probably the second one will also taste really good because you're still very hungry. But as you will be eating more and more of these sandwiches, you will be feeling more full, more fulfilled, and you can imagine that sandwich number 8 and number 9 and number 10 will not bring you the same amount of satisfaction. At some moment, you will be full and you will not take any pleasure in eating one additional sandwich, right? So, this is why we have such a shape for total utility function. It reflects the simple fact that the more of something we consume, the less we value each additional unit. And look, based on what we said about this, we can also say quite a lot about marginal utility. Why? Because the marginal utility should be decreasing function. Why? Well, we know that first derivative of marginal utility, right, is negative. So it needs to be downward sloping, right? So we expect this shape to look like this. But what is the logic behind it? Look, marginal utility is telling you how much more satisfaction you are getting out of eating first, second, third, one additional sandwich, right? And let's go back to the example with tiny sandwiches, right? So look, you're coming back to the party, first sandwich you grab, right, is the sandwich for which clearly you get the most satisfaction from, right? No? But then, a second sandwich will be associated with less satisfaction, and each additional with less and less and less additional satisfaction. This is basically what we call a law of diminishing marginal utility, and basically this is what we've been talking about for this time. When customers is consuming more of a given good, each additional unit brings less and less of additional satisfaction. Okay, and look, those two concepts, so total utility and marginal utility, are the two main concepts in entire customer choice theory. However, look, what we said thus far connects only to analysis of consumption of just one good, right? But even though we've described this artificial measure of satisfaction quite nicely. We matched it with, let's just say, with our observation of what is actually happening in the real world. So because of that, we are able to say something, but right, we want more. We want to include more goods. As it turns out, those two concepts can be easily extended to the case where we deal with more goods. And in those cases, we still will be using a marginal total utility. However, we're not going to be considering just one quantity of a given good, but rather what we're going to discuss are going to be bundles or baskets of goods. And this is going to be the topic of our next video. Thank you very much for your attention.